Good day, everybody. Demo 4 App Connect Enterprise Non Functional Testing with JMeter. Use case. If it is a banking or insurance domains, there will be millions of transactions for a specific web service. Hence, it is recommended to validate the performance of the web service in isolation. Performance testing was created with JMeter, such as with a load of 750 requests. Reports were generated for each test execution. Let me kick start the execution. So the execution is complete. Let us navigate to the reports. So this is the report which is generated for by the JMeter for this execution. So the apex is 0.068. So we have various statistics such as number of samples, that is 750. The minimum response time was 0.082 seconds. The maximum response time was 10 seconds, and 99 percentile it is around 10 seconds. There were no errors. There it 100% pass results were given. Let us navigate into the details. So this is the overtime graph. As the time elapsed, so initially the response time was minimal. As the time elapsed, the response time was higher. So these are the various graphs, such as this is the graph for. So this is the graph for the min response time. This is the graph for the median response time. This is the graph for the 90th percentile, and so on. This is the graph for active results, and the various graphs are given. Latency is important. The latency, that is the delay in the responses which we are receiving from the web service, has increased as the load increased. Let me navigate to the throughput. So initially the throughput was high, which is good, but as the load increases, the throughput has decreased, which is not a good factor. So regarding the response time, initially the response time was low, means the performance was good. As the load increases, the response time increased, which means that the performance was not good. So we have various other graphs, such as requests which less than 500 milliseconds, requests which are having more than 500 milliseconds, and between uh, 500 and 1500 seconds, and these are the various graphs. So the main thing to take from this statistics is the minimum was 0.82 seconds response time, and maximum was 10 seconds response time. Additionally, using the artificial intelligence and data science, custom reports are generated and integrated with Azure Pipeline, which provides insights whether the performance have deviation in last 10 build generation. This would be applicable only in the Azure pipelines. But anyhow, I would just execute it and give a high level insight about what the report is. So the report execution has completed. So this is the report which is generated. So here we are generating four type of graphs. One is min response time versus average response time. Another is min response time versus max response time. Min response time versus throughput. Min response time versus error count. Since there are no errors, this is blank, but it is if errors are there, right, it is good to have this graph. For last 10 iteration, what was the average response time? Whether there are deviations in the average response time can be inferred from this graph. The same goes with the max response time. If there are any deviation in the max response time, it can be inferred from this graph. For last 10 iteration, how was the throughput? This graph would give the insights. When a change is performed to a web service, it is good to have insight whether response time, throughput, and error count has deviated to make decision and promote to higher environments such as production. So this is about this demo. In the next demo, that is demo 5, App Connect Enterprise integration with Azure DevOps will be demoed. Thanks for your time, and thanks for watching.